that note, our guest today is Patryk. Came over here from Poland. He's been here for a while, been attending almost every event. I see you everywhere. GameDev and everything else. He's a graduate from Lublin University in Poland. He's the CEO of Lublin GameDev Foundation. He is also the head of games department at NetIns Software, and is also a teacher at that same academy and a longtime enthusiast of game creation. He eagerly takes on new challenges and explores new ways to create games using all kinds of new technologies. And he believes that the only thing better than playing games, just like I believe, the only thing better is making them. So thanks for coming out and speaking for us today and teach us some new stuff. So thanks for your time. Come on up.
So just one thing before I start presentation, I'm recording whole presentation because my friends back in Poland want me to do that. So I hope that you don't have problem with that. Okay, so thank you for having me here. And as this right now is international meeting, so I think that we should start with learning Polish. So probably you already know pierogi and kiełbasa. So I want to teach you one, well, maybe a little more Polish words. So cześć wszystkim means hi everyone. Okay. And to just encourage you to learn Polish language, this is a table of all plenty of variants of word play in Polish. Good luck with that. Wow. Okay, so let's go to presentation. Hi, I'm Patryk. So you can follow me on Twitter, email me. I will drop those contact info later. Don't bother. So I'm working on making games for more than 5.5 years. So I think I know something, but I'm not sure. I was using, for most of my career, I was using Unity because it's my favorite tool. But I was also using Unreal, Construct, and Default game engines. And you know, I think Unity is for me the best right now. Okay, so first of all, Lublin GameDev. What is? So back in Lublin, I'm CEO of this foundation. We are organizing networking, knowledge experience, meetings, bar camps, workshops, and game jams. And about those last one, I will have another speech on IGDA on a Tuesday next week. So I highly encourage you to go there. And I also
what's a bar camp?
Well, basically, bar camp is a presentation like this, but in bar. So you can drink beer and listen to some fun presentations.
That's what I thought it was.
Yeah, so this is how we roll. So how I get here? So a year ago, I was hired by this company, and also a year ago, Governor Sandoval came to Lubelskie, and especially to Lublin, to finalize friendship between Lubelskie region and Nevada. And well, a year later, we are here. And they just dropped 2 of us here, so you know, now we are international company. Great! So I'm proud of that. And so we have 2 branches in Poland, one in Wrocław, where we have our headquarters, and second one in Lublin, where I'm responsible for gaming department. And right now, third one, Las Vegas. How crazy is that? Okay, so design patterns. What are those? Do you know anyone? Okay, so no one is jumping to describe that. Okay, so design patterns are used. Well, basically those are a set of rules to follow. The goal of using design patterns are to structure your code, make it more readable. As I said, they provide some rules to your code, so other programmers have to follow them. That makes, well, everyone life easier, especially if you are working on project with multiple people. And of course, it improves your quality. So my goal today is to make sure that none of your 99 problems is related to design patterns. So why design patterns? Because I'm sick of poor quality code. So, and the only valid way to measure how good code is with WTFs per minute. So less is better. So I don't want to deal with that. So I'm trying to teach everyone about design patterns because this will make everyone's life easier. So let's go to design patterns. So of course, first one is highly related to high-level languages, and it's inheritance. I hate this example, but I can't find any other. So we have this base class, animal. We are extending this class with other classes, for example, cat or dog. So how this might look in code in your project? So I have an example for you. I'm not sure how much you can see, but let's try it. So I created simple movement script. So this is our, let's say, base class, where I just briefly describe what I want from this class, what I want to make it move. So we have simple this update method where we just reading inputs from keyboard in this example. And then, because I'm using a rigid body to move, I'm using this function later in next classes in fixed update. So this class do basically nothing besides reading the input. So how we can use inheritance to extend this to have do something? So over here I have example for let's say side view game. And in this example, our character behaves in such a way that simply follow keyboard arrows that I'm clicking. So with that, up is up, down is down, left is left, right is right. So with that, we are using inheritance and we are basically doing exactly that. So you see that this script is not as big as the previous one, but it makes the movement happen. And let's say we want to create another variant of the same, well, not the same movement, but again, movement for our character that will follow exactly same methods, but with little different logic inside it. So let me show you second scene. Oh, and in the meantime, if you will have any question, throw at me, I will try to answer those. So in this example, I have, again, same base class, but again, with movement, but this time, I'm again using arrows up and down to move my spaceship, but right now, if I want to go left, then I have to turn my spaceship and then go. So again, I'm using the same logic in base class, but a little different in class that is extending the base one. So difference is, well, simply over here. I just need to put a little. So you can see with using the same base class, this one, I created two separate, well, movements based on the same base class with just a little difference in terms of behavior. So this is how you can use inheritance in C# and in Unity. So what make inheritance great? So it adds flexibility. You will write less code, of course. It's easier to extend existing classes with new behaviors, such as the movement that I just showed you. And it also is good way to structure your logic. Or let's say you have like bigger picture, or you have like this whole layers of different logic, and you can split it, for example, in different classes. So it's simple, but it's powerful. So next one. Okay, I have to say that I hate this one, but I have to say, but I have to mention that why you don't want to use that. So Singleton pattern is basically, simplest description is that you have only one instance of this specific class. So if you call this class, or you will try to create one, you won't be able until it's not yet existing. So I was thinking how I can show you this class, or some kind of useful way for this pattern. So I just created, okay, example might be exaggerated, but the whole idea is to make, well, with Singleton you have access to this object from every part of your code. Well, depending on implementation, but in my case, this is it. So let's think that we don't want to really think about passing the whole references to specific place to make sure that it always plays the same sound when clicking, or in my case, it's a little different, but. So I have this button. Okay, you can't hear it. Okay, so just to show you implementation of that. So over there, I have audio manager, which is Singleton over here. And with this object, I have those click sources where I put sound of a click. And I want to be able to play this specific sound on every click. And to make it, I don't want to put sound source in each button, because I'm lazy. And I want to make sure that it was played in this specific place. So I just created simple UI click, and this is how you can call the Singleton. So we have this audio manager class, and over here we have instance of that class. So in our case, this is this object. And I want to play, well, in this example, random UI click, which is like simply randomly selecting this one of those. And it's playing this. And I really don't have any other good idea for using Singleton. I was thinking that maybe game manager might be a good idea to use it, but it also depends on what your overall code architecture is for game. So if you have you want to have like one manager for whole game, then you might think about that, but I think this is a very bad idea, because so let's talk about that. So only with Singleton we have only one instance. We can access it from any part of your code, but what I didn't mention, why I hate this, it requires discipline, because with Singleton you can go very wrong way with it. So, because something is accessible from every part of your code, developers tend to be happy with that and just put more and more and more in every part of your code. And if you decide to, let's remove this part of the game, but oh my, we can't do it because it's. So that's why I don't like to use singletons, because they tend to make mess in your code. So how you might ask how you can implement singleton? It's actually a pretty straightforward way to do it. This is it. And to make your class singleton, you basically have to inherit it from something like that. For example, that's all. And you have singleton. So in awake, well, we are looking for instances of that class, and if you find that we don't have any, then we should destroy ourselves. No, if you don't have yet any movement, no, sorry. If we find instance that is not us, that is not this instance, then we should destroy our object because, well, we can't have two of those. And then return, don't go further. And if we don't find any, then we just put the reference over here. And because it is static, we can access it from like this property. And depends on how you want to use it. Probably you don't want to destroy this instance, so you are trying this also. Next. Yeah. So next, observer. Basic idea for that is that we have some kind of object that is, let's say, sending some messages, or or we want to get notified if something happened. So with observer pattern, we can do it as we can like add more and more objects to listen for specific, let's say, event or something else. So in order to implement that, we have here. So let me show first implementation. So we will have our robot that just simply throws from time to time some text, so string. And we want, and this is the only thing that this robot is doing. So in order to implement observer pattern, we will have to need some kind of event or action. Do you know what the action or event is in C#? Someone? No? Okay, so basically this is just like collection of list of methods that will be called when we will invoke this thing. So we are invoking this action with a string because it requires it, and it just simply uses one of the codes that I put in this robot. So how observer will look like? Well, in a way, we just simply add our method that will listen to the message that the robot is serving, and then we will do something with it. So in that case, we have this printer that will print our message. And how this looks like? So, yeah, very. This robot is printing, sending new message every 5 seconds, I think. And you see that it's doing that exactly how it's supposed to do. And our observer is just watching our robot for those messages, and then it's just sending this message to UI to print it. That's all. We'll go further with this design pattern when we will go to the last one. So, go. So, yeah. So, for what reason this pattern is something that you might be interested? Because it's easy to extend. If you want to have more listeners, then sure, you can add new class that will listen to those messages, and then they will do something other with that. So for example,
Question about listeners. So if like you have a ton of objects that are all with listeners, is there any performance hit on that, or does it?
I think this will be, well, this will be just like going through the whole list of methods that have to be called. That's all. So those events just collect methods that we want to get called by the invoke method, and all those will get the message or something else that we want to print. So why this might be something interesting to you. So right now we have just this observer that will print this message to UI, but maybe we want something to send this message maybe to our server. So that's why this is great for analytics, because we can add analytics to whole game, and if we decided that, okay, you know, maybe we want to remove it and add some other implementation of analytics. And with that, we can just delete all those classes that are related to analytics and nothing happened. Because this is very, this is not depending on the code that you write, because this is something that just listen for event to happen. And as I said, you can add and remove your code to project without affecting other parts of it. So, yeah, just look around. In Soviet Russia, yeah. So another prototype, another pattern. So factory. Factory pattern or prototype is basically we have something that creates objects for us. Let's say in Unity they already implement that with instantiate method. So well, but nonetheless we can still want to use factory design pattern because maybe we want something to happen before we will instantiate or after we instantiate prefab, or we want some other thing to happen. So I have okay. So how this might look like? Implementation for factory. So over here we have this factory class. This is it. Nothing crazy. So there is a little more fancy logic over here, but nothing crazy because this class just spawn prefab every okay, half a second, or depending what else I put here. So yeah, there should be like 180 per minute. So if I run it, then yeah, they will just spawn every few moments. That's all. So, but you might think that, well, okay, it's fine, but how this will affect performance? So, yeah, I have to be prepared for that. Well, thank you. Basically what I said. And factory design pattern is also great for object pooling. Do you know what the object pooling is?
Yes.
Great! So let's talk about it. So object pooling is basically idea of reusing your objects that you've already created. So if you want to make object pooling happen, then we don't want to destroy instance that we already have. We want to reuse it. So after we finish with what we wanted the object to do, we just return it to our pool. So in our case that we showed over here, those stones were simply destroyed. And of course, with more and more objects created, we are adding also overhead to performance. So we don't want to do that. We want to happen. We want object pooling for that. So over here we have again same scene, but a little different logic. Over here, every instance that is already created, I'm reusing it. So you might not see this on scene, but you can see it over here. So let's say I want this one. So you see that as I selected this one, after 2 seconds, object is destroyed, and it's returning to our pool, which is over here. So how you might implement this pattern? It's also not something crazy. Well, a little bit, but not so hard to understand. So over here, again, we have same prefab, we have same method get instance, but we also have a method return instance. So at first, we have to check if we have already some instances created and we can reuse. So I have here a stack that I'm using for collecting all those objects. And if there's one, then I just pop from the stack. I'm just resetting parent for the object, and then I'm simply activating. If I don't have any object on my stack, then I just simply instantiate a new one, and then return to do whatever I wanted. And as object is no longer needed, then I just return it, and I just simply deactivate it, set parent to our pool, and then I'm adding it to our stack. That's simple.
Use a lot of ammunition in games.
Exactly. This will be the great example for that. So I'm using here stones, but you can also use it for bullets or anything more procedurally generated. And well, logic is not that different. I'm just so difference is over here. So over here I have just simple factory. After this timeout, I just simply destroy the object. And in that case, I'm just returning this instance to the pool. It's simple. I tried to run performance benchmark over here, but I think this is just too simple project and Unity is handled that without problems. So I can show you what the performance of those is. So,
but it's a cumulative thing over time too.
Yeah.
That's when you, if you keep creating instances and just deleting them outright, then you get garbage collection, and then your mobile game or
and also this affecting the scheme of memory. So with time, you also have problem willing with the fragmentation of memory. So a lot of problems. So using object pooling is great for things that we are creating every couple of seconds, and then we are destroying it. So why don't we just reuse it and destroy things? So yeah, other developers hate them because they know how to make optimal performance better. So another, fifth one, and this is one of my favorites. Of course, state machine. The whole concept of state machine is that we have states that runs part of our logic, and this might be great use case for AI or some other things, animations, for example. And I have also example for that. And as I said, AI. How simple it is to write AI based on state machine. So over here, I have state machine with basically two states. One, go to place. Second, wait. And you see that after some time, those states are changed because the wait is finished, or our friend over here just arrived at his destination. And this is a simple way to make, let's say, AI enemy that patrols the surroundings of some area in the game. And you can use it for whatever else you want. You can simply extend the behavior of our hero with adding more states. But of course, this will also will require some thinking about how to do it and when you want to change the state. So you might ask how I can implement state machine. Let's close it. Okay, so this is whole implementation. So we have this base state class. I will show you. And with this base state class, we have just 3 methods and state machine, of course. So first, as we engage our new state to state machine, we want to prepare it. So we are also passing the reference to state machine. So it's fine. Also, I want to have access to our update loop because this class is not extending mono behavior. I don't have any start, await, any of Unity methods that I might use. So that's why I'm using update state. So this method will be called in update by state machine. And also, as this state is no longer needed, I need to destroy it. So, as we have this settled, on awake, I'm just simply assigning wait state to our hero. That is simply changing state. So on the beginning, I won't have any current state assigned, so this won't be execute. But if you will have some, then we will destroy this state. Then we are assigning new state to current state, and then again we are preparing our state. We can also call this method with null, so we won't have any existing state within machine state. So with wait, we are also extending those methods. So again, we have the inheritance. English. And Polish is hard, yeah. So on prepare state, I just simply randomize wait time from 1 to 2.5 seconds. Then in update, I'm just simply subtracting delta time, and after it will go below 0, I just changing state to move state. How simple is that? And of course, with move, something very similar. I'm just assigning some random point in space where our character will move, and again some math to have direction where we should go. And as we arrive at our destination, we are changing again our state to new wait state. That's it. So, any questions until now?
I got one. Why are you choosing to delete your state before? Was once you override your state with the new state, why are you specifically?
Because maybe you are. Well, I will show an example in the next pattern, but over here, maybe we have some other logic. So let's say our wait state subscribes to, let's say, object or that we subscribe, and then to receive some messages from, let's say, again, our robot from the observer pattern. And if we won't have destroyed state, then we can't unsubscribe from it. So this is especially useful for, let's say, adding analytics or assigning to events in MVC or in view. We will go there. So I will show you in next pattern, but let's finish it. So machine state is pretty straightforward to manage. We have just those states that we have the whole logic. It's easy to extend with adding new states, and each state is responsible for its part. So in our case, wait is waiting, move is moving. And it's great for multiple things. Of course, AI is one of them. Unity is using also this for making animations. And well, I'm also using this in next pattern, and I will love it. Good. So it's also tempting to make more states within other states, and you have to be careful with that. So the last one that I have for you today is MVC, or Model View Controller. And I really like it. I fall in love with it. I'm using it for every project for over one and a half years. And it's great. And how this things works. So we have these three component pieces of this whole MVC model. So controller, of course, is responsible for controlling things, and probably is something related to logic. It should be here. Model just stores data, nothing else. You don't put any more complicated logic on top of data. If you want to do that, go here. And view, of course, is responsible only for viewing things. You don't have any logic also over here. So how it might look in code? So this might be something interesting because this pattern is a combination of many patterns that you already see today. So in my case, I love using state machine as a controller because it gives me so much flexibility. Because with that, I can create state for each, let's say, view. In this case, we have menu state. Let's play a game. We have game state. And of course, finish state. So those are three states that I might create using state machine inside controller. And of course, with states, I can go back and play, or go straight back to menu. And of course, I will have to go again to finish one. So, as I said, in the core of my controller, let's say this is it, we have simple state machine. Nothing crazy about it, that's it. I also have those two things. So, of course, UI, so view, and data storage that I'm using for storing data. So, you ask about why I want to use destroy state or not simply just override it. Because if I'm using observer pattern to assign all those methods, well, assign my methods to UI events, then I need to unsubscribe from them. So in that case, you see that in menu state, I just have simply this play button, nothing else. So in prepare state, I'm assigning my play method, play game, so this one, to event in menu view. And then if I go to another state, then destroy state will be called, and I have to unsubscribe from the event. So, okay, this is the logic part. How it might look in view. That's all. This is only thing that is in menu view. So I have just this method play. Nothing else. You can see over here, menu, we have this play button. We have assigned this click over here to our menu state, and it's everything over here. So if we want to decouple it, well, if you want to remove menu view and play somewhere else, we don't have to worry about like doing much, because we just simply need to remove the assigning events. That's all. We don't have to pass any other references, and this is that simple. And with game, of course, the same thing. We have this finish button is also assigned to this finish method. And if you decide to extend game view, or let's say remove game view completely, or do something else with it, we just simply throw it away. Or if you want to change game state for something else, then we can throw game state completely. We don't have to worry about this UI part. But actually in game, let's say that we really have the game implemented. So we actually play it. So after we finish our game, we want to store data about how the game was like, how points players scored, or how much time it takes to finish this level. So actually, okay, let's say I have to randomize it. But this is model. So model is just a data, nothing else. So you can see that our model has two properties, or two variables. So it's played time, so how much time it took the player to finish level, and of course score, how many points player scored. Don't worry about that. Let's say we have implemented games. And simply, with that, we just simply put the model inside our data storage. So over here, we are saving our data to, let's say, our storage. I'm using over here dictionary to save this data, and then if I need to get it, then I'm checking if I have it or not. And let's say after we finish our game, we want to read this data and put it later to UI. So, not here, over here. So again, we are assigning our events to UI to run our logic. We are getting data from our data storage, so we are getting our model. And then later we are putting this model to UI to show it, and of course show UI. Nothing crazy. And we are not using views at all for any kind of logic. We are using view only to display and listen to events that player did. So of course we have those two buttons, and we are showing result of a game over here. That's all. We are not putting any other logic in view part. So with that said, for me, MVC is really great pattern, especially for structuring your code, because you have to follow those rules that the only logic that you have is inside controller part. You are not doing any kind of logic in view or in model, besides processing maybe. And it's amazing, because it's make people think when they where they need to code their code. So each piece is of course responsible for its part. So UI for displaying things, controller for controlling things and having logic, and model is just for storing data. And I found that this design pattern is great for working with multiple developers, because you are also making other developers, well, you are forcing other developers to work within this pattern, so overall quality of the project is going up, and this is why we want design patterns. So, with that, with knowledge comes great responsibility. So you have to make a word, go make better codes, make every senior developer read your code in code reviews, makes life easier. So to sum it up, we showed all those 6 design patterns. Well, of course, inheritance is the simplest one. Singleton Observer is also really great, especially for adding analytics. I have other projects that I later might show you where I use Observer Pattern for analytics, and it's amazing, works amazing. Factory is great for Factory and object pooling is great for creating many instances and reusing them, especially for bullets, or if you have procedurally generated levels and obstacles, use that for it. Of course, machine state is great for many applications, and MVC is great overall. So, do you have any questions at this point? Go ahead.
So, going back to Observer, question about that. Oh, okay.
Okay.
You can do it from the wide view. There you go. So, the example you gave had one iteration, right? That was doing quotes.
Yeah.
Right? Let's say it's a robot that's that's just spouting quotes. Right?
Yeah.
How do you work with observers if you have 5 robots that are all doing quotes?
Well, you can still use the same thing, but then you will have to. Okay, let's find it. Oh,
I know this is 4 topics ago.
it's over here. So, well, it doesn't matter because we can simply make this. And all those other robots will also call this method. So, actually, not much changed.
But how does it separate between, like, if you have robot 1, 2, 3, 4, 5? How does it know which one comes from which robot?
Okay, so with that, in this implementation, you can't do that, but we can change it. So let's say our robot will also tell which one is it. So let's make our method send 2 strings. So quote will be second one, and first one will be just simply game object name. Yeah, and here you basically need to add string, robot name, and then maybe combine them over here. So robot name. So with that, you have it. Any other questions?
With the NVC model, where do you believe, like if you reduce a scriptable object, would you want to put that more in the model or in the controller? Because it's kind of a little bit of both.
Yeah, actually we use scriptable objects for one of our other games, where we put, well, we use scriptable objects as more controller, but that one that use also some data from other parts. So in simple words, we make scriptable objects our game modes. So we just then simply in state machine, we just simply put scriptable objects as they were responsible for making all of different game modes, and then we will run it like at the other state. That's how we did that. Yeah, I don't think this is time to show it, but it worked that way.
Okay.
Over here. Okay. So, if you have any other questions, then send me email, send me tweets, send me whatever else you want. Here are my details. I have already presentation and all this code in Google Drive, so after a meeting I will send it to Meetup comments or to Alex. And after, well, I will need a few moments to process the video, so also you can see the presentation on YouTube. So, thanks. Whoa. Okay, so this one
video, you're gonna put up Polish subtitles?
Okay, well, I might think about it.
Just use the
You're
real
really
hot
long.
one.
Yeah, definitely. Okay. So, thanks again, and well, actually.
How long are you staying here in the States? Are you permanent then, or?
No.
Okay.
Well, not yet. We are staying in, well, Nevada till mid of December. So plenty of time to make other presentations. Yeah, and as I said, if you want to learn more about game jams and
Yeah.
I have a question for you.
Uh-huh.
I'm just curious, you schooling, is it being taught in Polish, or is it a combination of Polish and English, or how do they, for technology things, how does that work?
well, I learned English by playing games.
Okay.
And you know, well, in university they have this weird behavior because they try to teach you how to code, but you also need to learn writing code in English. So you have to sometimes navigate that.
You can't just code in Polish? That doesn't, you don't have to?
Well, you know, there was one language in which you can program in Polish, but with all those our weird letters, it's
not a big thing.
it's a bad idea.
Well, I'm just curious. Thank you.
It's easier to pick up English.
Yeah, and you know, I'm happy because in Poland, actually writing English, well, working in IT requires you to know English and write your whole code, manage all your tasks in English, because I have few times pleasure to work with code created in, let's say, India or China. Well, you can read the code, but you can't read comments, and sometimes this is important.
So, one more question for you.
Uh-huh.
So, using, okay, for like example, the pools, right?
Mhm.
Using stats versus using some arbitrary array that holds the objects,
Mhm.
right? And just cycle through the array. Aside from the obvious, you know, simplification for code for a team, the stuff you're showing, does that also affect performance, or is it just the legibility for a team to integrate and use correctly?
Well, for object pooling, well, I use stack. Well, you can use a whole bunch of other arrays. You can use array, you can use list, you can use hash list, you can use whatever, you name it. Well,
Performance-wise, that they're all pretty
well,
much.
you know, this is something not a big difference. Maybe if you like spawning thousands of them, then it might affect performance, but in game case, probably if you spawn, let's say, 10 per second, it's okay. Not a huge difference.
So it's just it's better for a team.
Well, the most important thing in code is to make sure that other team members understand it. So this is why you should add comments, and not much people did. At some point I was a comment freak, and I just comment every other line. But I'm again at this point where I just make sure that my code is readable, so people can just read it. Yeah. Cool. Okay. So.
Thanks, Patryk.
Thanks.